Hello and welcome to the continuation of Lesson 8.4 over trigonometry. And so we're going to pick up where we left off after finishing up some of the notes in class. So we talked about sine, cosine, and tangent. We figured out that those ratios represent the ratios of different sides of right triangles. And we also looked at how to enter sine, cosine, and tangent into our calculator if we know the angle measures. And so we're going to use the combination of those two ideas to help find unknown sides of triangles. Now, in these examples that you'll see, we will be given an angle measure in one side and asked to find a second side. If we were given two sides and no angle measure, we could find the third side with the Pythagorean theorem, but since we don't have enough sides, we need that angle measure to be able to use our trigonometry ratios. So here's how we would find unknown side lengths, and I've given you a 5-step process to follow every time so you can kind of keep this with you as you're working through these problems. The first is to identify the reference angle. Mark an arc across it. So whenever you see that angle that they give you the measure of, go ahead and mark an arc so we know that is our reference angle. Okay? Then we're going to label only the two sides, the one we know and the one you want to find out. Okay, the one we know, the one we need to know. So we're going to label those sides as either opposite, adjacent, or hypotenuse. That's what we're using for our labels. And so we're going to look at these in reference to this reference angle. The 18 is representing this leg, so it's either opposite or adjacent, and it's next to this 25-degree angle. So this is our adjacent leg. And we're looking for x, which is the other leg or the opposite leg. This tells us whether we're going to use sine, cosine, or tangent from this acronym, SOHCAHTOA. TOA. That's what we're going to use. These two labels, notice I did not label h. I don't need the hypotenuse. I don't need to find the hypotenuse. We're only using the opposite leg and adjacent leg. Since I'm not using hypotenuse at all, these parts tell me that I'm going to use tangent. So I'm going to use the tangent ratio of the number of degrees of the reference angle, 25. Okay, so we're just writing our equation, the trig function, and then angle in degrees, so sine, cosine, or tangent, and then the angle measure. We've decided we want to use tangent because we're using the adjacent to find the opposite, so we're using O and A. Equals, and we want to write that fractional ratio of those two sides we're using. Remember, tangent is equal to the opposite leg over the adjacent leg. X is the opposite leg, 18 is the adjacent leg. And then this is just an equation. Now, you could set this up as a proportion, and that's how we're going to do these. But in order for this to be a proportion, this side needs to be a fraction. So I'm going to take this value over 1. And to use a proportion, to solve a proportion, we just cross multiply. We take the cross products and set them equal. So we're going to take 18 times that tangent of 25. This is a value that we're going to put in our calculator. Okay, so I'm going to do 18 times that. So I want to write 18 times the tangent of 25 equals 1 times x, or x. So in this case, all I have to do now is enter this value in the calculator. So I'm going to use my calculator here. We're going to enter 18 times the tangent of 25. If you have a newer style calculator, we can do this all at once. 18 times tangent of 25. Might be helpful to close that parentheses, then hit enter, and it'll give me my final answer for x. And we are to round to the nearest hundredth. That's 2 decimal places, so x is approximately 8.39. All right, let's try that again with this example. Follow these steps again. Identify the reference angle. So here's our 70-degree angle. I'm going to put my arc through it. I'm going to label only the two sides that we know and the one I want to find out with either O, A, or H for opposite, adjacent, or hypotenuse. We are given this leg, which is right next to the 70-degree angle, so it is an adjacent leg. And we are trying to find the value of x, which is across from the 90-degree angle, so that is our hypotenuse. Now I want to select the correct sine ratio. If I'm using the adjacent leg to find the hypotenuse, I'm using A and H, I'm going to use cosine. So cosine of that 70-degree angle is equal to, I'm at step 4 now, writing my equation. Cosine of 70 is the adjacent leg over the hypotenuse. Almost said it wrong. The adjacent leg is 15 over that hypotenuse x. And remember, I said the best way to solve these equations is to turn them into proportions. All right, so I'm going to set up that proportion, cosine of 70 over 1 equals 15 over x, and we just cross multiply. 70 cosine of 70 times x, we're going to write as x times the quantity cosine of 70. Sometimes it helps to put parentheses around that because that's one value, equals 1 times 15, which is 15. Well, in order to solve this for x, remember this quantity is one value, so to undo the multiplying by that value, I'm just going to divide by the cosine of 70 on both sides. So here they cancel, and I have x equals 15 divided by cosine of 70. And so I can use my calculator and do 15 divided by cosine of 70, and close your parentheses. And we get that x is about 43.86. Now, what we've just found are length measurements. So if there were units of measure, we would have to include those. Okay, if let's say this was 18 feet, x would be 8.39 feet. If this was 15 meters, x would be 43.86 meters. So just pay attention to whether or not you need units of measure. All right, now to take a look at how to finally put this all together, there is one other side of this. And that's using what we call inverse trig functions. An inverse trig function is how you would cancel out one of our trig functions. So it's like saying the opposite trig function. The opposite of sine of angle A equals x is the inverse sine of x equals the measure of angle A. If I'm giving you an angle measure already, we're just going to use our trig function, sine, cosine, or tangent. But if I'm giving you side lengths and asking you to find an angle measure, we need to use the inverse trig functions, and I'll show you why and how to do that. And so we have inverse sine, we have inverse cosine, and we have inverse tangent. Okay, we can also call these arc sine, arc cosine, and arc tangent instead of the word inverse. But we write them this way and we say them either of these ways. Okay, sine to the -1 power is what that looks like, but we're not using negative exponents at all. We are just using that symbol to represent inverse sine, inverse cosine, inverse tangent. Okay, so if the sine of angle A equals x, then the inverse sine of if the sine of angle A equals x, then the inverse sine of x equals the measure of angle A. Okay, and we get that this way. So let's say I had this. If I have sine of A equals x, what we actually end up doing is taking the inverse sine of both sides, or the arc sine, okay? So this side is now inverse sine of x, of that ratio, equals the measure of angle A, because inverse sine cancels out sine. These are just inverse operations, they cancel each other out. And the same could be done for cosine and tangent. So here's our steps for finding an unknown angle measure. Okay, first we want to identify the angle you need and mark it. Okay, and now here's where this gets a little bit tricky. We get to decide which angle we're going to use based on the given side lengths. Okay, since I'm only given these two sides, I can either use angle A or angle B, but often they'll tell you which angle it is we want to find. So I wouldn't want to use angle B if I'm supposed to find the measure of angle A. Since I'm finding the measure of angle A, I'm going to mark that angle by putting an arc through it. And then I'm going to label the two given sides as either O, A, or H, opposite, adjacent, or hypotenuse. So if this is our reference angle, these are both the legs. 6 is the opposite leg, 20 is the adjacent leg, because it's next to angle A. And so since I'm using opposite and adjacent, I'm going to set up an equation using the trig ratio tangent, because I have opposite and adjacent. SOHCAHTOA tells me I should use tangent then. So I'm going to say the tangent of angle A equals the ratio, okay, it says you can put an x for an unknown angle measure, but we could just use capital letter A. The tangent of angle A is equal to the ratio 6 over 20, because that's opposite over adjacent. Now, I could reduce that ratio and make it a whole lot easier on myself, so I'm going to write it again. Again, you could write tangent of x or tangent of a. These can both be divided by 2, so that's 3 over 10. Okay, it might be helpful to recognize that that's the decimal 0.3. Might make it putting in your calculator easier. Okay, since we want to find the measure of angle A, what we would do then is rewrite the equation using the inverse trig function. If the tangent of A equals that ratio x, 3 over 10, then the inverse tangent of that ratio equals the measure of angle A. So we're going to switch this around and say the inverse tangent, not of A, of 3 over 10, or 0.3 if you want to write it that way, equals the measure of angle A. And then all I have to do is put that in my calculator using the inverse button. And here's how we do that. We're going to use our second or function key to do that. So if I'm going to enter this in, I'm going to start by using the inverse tangent. You'll see printed right above it that TAN with a -1 exponent. And to get that, we have to push the second button. So I push second, and you'll see it brings up inverse tangent. And then I can put my 3 over 10 fraction. I can write it as 3 divided by 10. Or I can do 0.3. Either way, they mean the same thing. 3 over 10 is the same as 0.3. Hit enter, and it gives me this, which is an angle measure. So the measure of angle A is approximately, we're rounding to the nearest tenth, 16.7 degrees. Okay? So let's try that again for part B. We're going to mark the reference angle with an arc. So here angle A is that one. So we're looking for the value of angle A. We're going to mark the two given sides as either opposite, adjacent, or hypotenuse. 3 is the leg that is next to angle A, so that is adjacent. 15 is across from the right angle, so that is the hypotenuse. Since I'm using opposite and hypotenuse, the A and the H are together with cosine, so I'm going to set up my cosine equation. The cosine of angle A, I don't know that angle measure, so I have to write A, equals the ratio of adjacent leg over hypotenuse, 15. Again, simplify that fraction if you can. Cosine of angle A equals 1 over 5. Now 1 over 5 is also 0.2. So either way you write, that's fine. And then we want to undo cosine by taking the inverse cosine of this ratio equals the measure of angle A. So we're kind of switching spots with the A and the 1/5 when we do inverse cosine. And so the measure of angle A is just the inverse cosine excuse me, of 1/5. Now, to do this with an older style calculator, you're going to have to enter the number first. And so if you're writing the fraction, remember that's just division. We do 1 divided by 5. Or you might already recognize the decimal. So we're going to enter that number first, and then we're going to hit our second key, and then our cosine button to get that inverse cosine. You can see right above it. And that gives me the measure of angle A is approximately 78.5 degrees. All right, and that wraps up our lesson on how to find missing values of triangles, whether you're finding an angle measure or finding a missing side. If you're finding a missing side, you'll just use sine, cosine, or tangent. If you're finding a missing angle, you will use inverse sine, inverse cosine, or inverse tangent.